Okay, so today I'd like to talk about a very important topic in algebra called solving linear equations. And in this video, I want to talk about one-step equations, what we call one-step equations, which basically means that you're only going to need to do one thing to this equation to be able to solve it. Now, I've got two examples up here to begin with. And so I want to discuss kind of the ideas of this. And so if I take a look at the first example off to the left, I have x plus 6 equals 15. What I want to do is I want to solve an equation. Solve means to algebraically isolate the variable. In other words, I want to get the x all by itself. You'll notice next to the x is a positive 6. And so what I'm going to do is I'm going to subtract 6. If I subtract 6 on the left-hand side, I also have to subtract 6 on the right-hand side. And so that will keep the equation balanced. When I do that, you'll notice here that the 6's cancel. Those are inverses of each other. And so I am going to be left over with an x equals 15 minus 6 is 9. That is my first equation. If I go over to the next equation off to the right hand side here, you'll notice here I have x minus 2 equals 8. What I have next to the x is I have a negative 2. What I want to do is I want to get rid of that negative 2. So I'm going to go ahead and get rid of that 2 by actually adding 2 onto this side. Well, if I add 2 to the left, I also must add 2 to the right hand side of the equation. I'm very careful when I'm dropping down my work. Many times I actually like to just copy down my equal sign. My equal sign should always line up here. You'll notice here that my negative 2 plus 2 cancels. It equals 0. You don't have to write down 0. I'm going to go ahead and copy down my x here. Those cancel, and this is going to be 8 plus 2, which is 10. Okay, so for my second set of equations here I want to discuss, you'll notice in my first set I had to use addition and subtraction to be able to solve or to isolate the variable, get x all by itself. In these two scenarios here, I'm going to require to use either multiplication or division. And so if you'll notice on this first equation here, I've got 2x is equal to 18, and so I want to get rid of this 2 that's in front. That is actually 2 times x. Even though there's nothing in between there, it is actually implied. I'm going to go ahead and divide by 2 on the left hand side. If I divide by 2 on the left, I'm also going to divide by 2 on the right. You'll notice here that the 2 over 2 cancels. That becomes 1, also known as 1x. I'm going to go ahead and copy down my equal sign. My equal sign should always line up. And 18 divided by 2 gives me 9. There is my answer on the first equation. Moving over to the second equation here, you'll notice that I have x actually divided by 3. This is division. The inverse operation of division is multiplication, and therefore I'm going to multiply by 3. Now, I like to actually put my 3 in a set of parentheses. It keeps it kind of organized, and so whatever I do to the left, I multiply by 3 on the left. I'm also going to multiply by 3 on the right. You'll notice here that the 3 over 3 once again cancels, just like the 2 over 2 did. And what I'm left over with remaining is x is equal to 12. You'll notice on both of these equations, when I solved them, it only required actually me to do one step. The first two equations that we had required addition or subtraction. The second two required multiplication. I have one more example that I want to give here. Okay, so this last example is kind of an odd one out here, but you'll notice that there's a fraction in front of this. This also can be solved actually using one step. Now you'll notice in front of this we have what's called a coefficient. A coefficient is just a number that's in front of a variable. I have a coefficient of 2/3, and what I would like to do is I would actually like to get rid of both the 2 and the 3 at the same time. Now if you remember, when we were dividing by 3, we had a division sign. We required to have a 3 in the top. That 3 in the numerator will actually cancel the 3 in the denominator. If you remember also, when we had a 2 in the numerator, we simply divided by that. So what we're able to do here is we're actually able to multiply by what we call the reciprocal. I'm going to flip the 2/3 over by 3/2, and I'm going to multiply by 3/2 on both sides. Whatever I do to the left, I also must do to the right. So I'm going to go ahead and multiply by 3 over 2 on the other side. On the left-hand side, you will notice that the 3 cancels with the 3, and the 2 cancels with the 2, and thus I have isolated the variable by leaving my x alone all by itself. On the right-hand side, I've bumped into a pretty common scenario that we bump into in algebra, in which I actually need to multiply a whole number times a fraction. So what I need to do first before I can do this is I actually have to turn that 12 into a fraction. The way I do that is I simply put over 1. 12 divided by 1 is also equal to 12. Now, if you remember multiplying fractions, I can just go ahead and multiply straight across. 12 times 3 gives me 36, and 1 times 2 is going to give me 2. Last step that I can do here is I can actually divide this out. 36 divided by 2 is 18. Although technically this did take us 2 steps, we actually consider this a one-step equation. And the reason why is that there was only one thing that we needed to do to isolate the variable. At the end, we simply just needed to reduce our fraction. And so this is still considered a one-step equation. I hope this helps you with one-step equations. I hope you have a great day.